one of the most difficult problem in this section, and one should attempt it only after attempting the easier questions. Here we have six friends who decided to play a game of die. The number on six faces, which were from 1 to 6, they divided themselves into three groups, G1, G2 and G3, with two friends each. They played two rounds of the game. In each round, all the players threw the die once, and absolute difference between the face values obtained by the members of each team was calculated, which means if G1, G2, G3 comprises P1, P2, P3, P4, P5 and P6 respectively, the game is of the nature wherein each of the players of any team, let's say G1, throw die, and if the number obtained are n1 and n2, the difference between these two numbers is computed, and that is known as AD. The team with the lowest, second lowest and highest AD was declared the winner, runner-up and loser respectively. If AD of a team is lesser than that, that of the other team, then the first team is considered to be placed better in ranking or in position. The winner got 30 points, runner-up got 20 points and loser got 10 points. And the table below shows points obtained by the teams in two rounds. In first round, G1 got 30 points, G2 got 20 points and G3 got 10 points, which means in first round G1 was winner, G2 was runner-up and G3 was loser. And in second round only we know the points obtained by G1, and this is 30, which means G1 was the winner in second round as well, but we can't comment on the standing of G2 and G3. Some additional data is also given. In first statement it is given that the sum of ADs of three teams in round 1 was less than that in round 2. This is first thing. Second thing, out of the four numbers obtained by the two players of G2 in two rounds, at least two were odd. And third statement is the sum of the four numbers obtained by the two players of G1 in the two rounds is not a prime. And finally it is given that no two friends got the same number on the die in any of the rounds. Also no two teams had the same AD in any of the rounds. This part of info is very important, and we can start solving this set with the help of this information. We have six numbers 1, 2, 3, 4, 5 and 6. Now we need to check what are the possible ADs, and difference of any two numbers out of these six could lie from 1 to 5. So one may think of the total number of triplets of AD that can be formed will be 5C3, which is 10, but this is not possible as all the triplets like 1, 2, 3, 1, 2, 4, 1, 2, 5 would not be possible. Only some of them would be there, and these are 1, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2 3 4 and 1 3 5. Only these ADs can be obtained, as it is given that AD of no team is the same in any round, and it can also be noted that the sum of ADs in first possible case is 7, and in second and third it is 9 each. It is given in a statement first that the sum of ADs of three teams in round 1 was less than that in round second. So ADs of the three teams G1, G2, G3 in round first was 1, 2 and 4 respectively, and in second round there were two possible cases. AD of 1, 3, 1, 2 and 4 can be obtained in two different ways. These are 2, 3. Difference in that case will be of 1. 4, 6. Difference will be of 2. And 1, 5. Difference is of 4. And there is one more case. This is 4, 5. 1, 3. And 2, 6. There is no concept or pattern as such to find these pairs. There is only one way to do so, is observation. Through observation we have to see what are the possible ADs, and after that we have to see what are the pair of numbers that would give the required ADs. Now coming to the second case, this is again possible in two ways: 2, 4, 3, 6, 1, 5. As 2, 4 will give difference of 2, 3, 6 will give difference of 3, and 1, 5 will give difference of 4. And similarly 3, 5, 1, 4 and 2, 6. And finally in the last case there is one and only one possibility, and this is 3, 4, 2, 5 and 1, 6. Now we have got to check the compatibility of ADs of round 1 with the ADs of round 2. When we take 2, 3, 4, 6 and 1, 5, then we see according to this second condition that the out of 4 numbers obtained by two players of G3 in round 2, at least 2 were even. This condition would get satisfied only when 2, 3, 4, 6, 1, 5 is taken up with last case, that is 3, 4, 2, 5 and 1, 6. So in round first, standing of G1 is 2, 3, and in second it will be 3 4 only. Of G2 it will be 4 6 for round 1, and for round 2 it can be either 2 5 or 1 6. And similarly for G3, in first round it is 1 5, in second round either it is 1 6 or 2 5. Now when we take the second case of ADs of first round, that is 4 5, 1 3 and 2 6, there is only one possible case of AD in second round as per the given condition, and it is of 2 4, 3 6 and 1 5. So let's write this on the next slide. R1, R2, G1, G2 and G3. This is 4 5, 2 4, 1 3, 3 6, 2 6 and 1 5. Now these are the possible arrangements of ADs. Let's move to the question. In first question it is given that if three players got the same value on the die in both the rounds, what was the value on the die of the player in G2 who got the lowest value in round 1? This is possible in the case when G1 gets 2 3 in first round, G2 gets 4 6, G3 1 5. In round 2 G1 gets 3 4, G2 1 6 and G3 2 5. Here 3 is common for G1, 6 is common for G2 and 5 is common for G3. And here we have to check the the value on the die of the player in G2 who got the lowest value in round 1, and this is 4, as the points number obtained on the die by players of G2 in round 1 were 4 and 6, and 4 is the minimum out of these two, therefore option B is the correct answer. In the second problem, if the three players from the three teams same got the least values in their respective team in both the rounds, what is the minimum possible value of the sum of two values in round 2 of any of these three players? And this is possible when points are, rather numbers on die are 2 3 for G1 in round 1, 3 4 in round 2, 4 6 in round 1 for G2 and 2 5 in round 2, 1 5 in round 1 for G3 and 1 6 in round 2. Here we have to find the minimum possible value of the sum of two values in round 2 for any of these three players. And if we see points of num, values obtained on die for player G3, we see 1 and 1 in the two rounds. Therefore the minimum sum is of 2, for which team no two player could get 4 on the die in any of the two rounds. From the given arrangements, we can say that this is possible for G3, as none of the players of G3 got 4 on the die in any of the two rounds. Therefore option A is the correct answer. In the last question it is asking which team could definitely not get the same AD in both rounds. Again, on the basis of the cases that we have, in one of the cases G1 got the same AD of 1 in both the round, and G3 got the same AD of 4 in two rounds, but in none of the cases G2 got the same AD in the two rounds. Therefore required answer is option B. That's all in this set.